All right, kiddos, we are here today to learn about measurement and data. Go ahead and follow along with me and take notes as you watch the video. Just a reminder, you can pause, rewind, fast forward, and revisit the video anytime you need throughout the lesson or throughout the notes. All right, first we're going to talk about data tables. Data tables is something you've guys seen before, I'm sure, in different labs. Data tables help you organize and record the data you collect in a lab. They generally have two columns. They can absolutely have more depending on how complex the data it is you're collecting. The two columns usually represent your independent and dependent variable in an experiment. Just to remind you, an independent variable is the thing that you deliberately change or manipulate, and dependent variable is what's going to change in effect of changing the independent variable. The unit of measurement should be included in the top column heading. You should not label the data you record in the table, just at the very top. So for example, if I need to record 32 centimeters, instead of writing 32 cm, I would just write 32. And at the top heading, it would say centimeters or cm. So the people reading the data would understand what unit of measurement is being used. All right, graph types. There are three main graph types we're going to talk about: scatter plots, bar graphs, and circle graphs. Scatter plots are used to show relationships between two sets of data. Bar graphs are used to display and compare data in a number of separate categories. And circle graphs are used when showing how each group of data relates to all of the data. Graph patterns. There are two different types of graph patterns: linear and nonlinear. Linear graphs are created when the relationship between the independent and dependent variable can be shown in a straight line. Nonlinear graphs are the opposite. It's when the relationship between the independent and dependent variable cannot be shown in a straight line. All right, measurement. Measurement is a description that includes a number and a unit. So for example, if I have 40 grams, 40 is my number, grams is my unit. We are going to be learning about the metric system. The entire world uses the metric system with the exception of us, the United States, and one other small country. So it's important that we understand how to use the metric system so we can share data across countries. The metric system is extremely simple because it is based on 10. It is also known as the International System of Units, or SI. And like I said previously, it is the most widely used system in the world. All right, the base units for the metric system: length is meter, temperature is Kelvin, mass is gram, and volume is liter. Hopefully these look fairly familiar, that you've seen them before. Okay, abbreviations are important. You cannot make up your own abbreviations. You have two options. You spell out the unit of measurement completely, or you abbreviate using the correct abbreviation with capital or lowercase letters. So for example, kilometers needs to be lowercase k, lowercase m. Milliliters needs to be lowercase m, capital L. Liters is a capital L. Meters is an M, centimeters is cm, and millimeters is mm. Again, the capital and lowercase letters does matter. Conversions. It's important to know that kilo is always going to mean 1,000. Hecto is going to need 100. Deca is going to mean 10. And a base, which is a gram, a meter, or a liter, is going to equal 1. Deci is going to be 0.1. Centi is 0.01. And milli is 0.001. This probably doesn't make a whole lot of sense at this point in time, but just understand that kilo is going to be your larger unit of measurement and milli is going to be your smaller unit of measure. Now, the stair step is a great method to help you convert different measurements in the metric system. The stair steps go up and they get larger in the measurement of unit as they go up. So kilo right here is our largest unit of measurement, and milli at the bottom is our smallest. As you go down the stair steps, your number will get larger because the unit you are measuring is a smaller unit, so you'll have a greater number. As you work up the staircase, your unit will get smaller because the unit you're measuring is a larger unit. Let me give this to you an example that you'll understand. Think about feet and inches. Inches are obviously a smaller unit of measurement. So if you have 3 feet of something, you're going to have way more inches than 3 feet because inches is a smaller unit of measurement. Same thing with the metric system. Okay, so we're going to start with some examples here. We are starting with 300 kilometers is how many meters. So the first thing you have to do is determine where you start. In this instance, we start at kilometers, which is right here. Then you have to determine where you're going. We're going to meters, which is a base unit right here. And so we hop. And we go 1, 2, 3. And that means we move our decimal 3 times. Our decimal right now is imaginary behind our last 0, so you bounce 1, 2, 3, add in your new decimal, and now you add your zeros in. 1, another 0, 2, and one more, 3. And our new answer is, don't forget to put in a comma, 300,000 meters. And I'll highlight that in yellow for you so you can see it. All right. Okay, we're going to try another example. This example gives us 0.0034 kilometers, and it's asking us to tell us how many centimeters that is. So where we start is we start at kilometers because that's what we're given right here. And where we're ending, we're going to end at centimeters right here. And now we bounce. We go 1, 2, 3, 4, 5. And that means we move our decimal 5 times. So up here we move it 1, 2, 3, 4, 5. New decimal. Whoops, that didn't stick for us. Let's try again. 1, 2, 3, 4, 5. New decimal. And we have to add in a 0. 0. Right there. So our new answer is now 340 because we no longer need the zeros in front. You don't have to put the decimal because it's behind our numbers, but we do have to label, and we abbreviate CM. There's our answer right here. I'll highlight it for you so you can see it. 340 centimeters. All right, let's try our next example. This one gives us 4,500 millimeters and is asking how many meters. Now this one's going to be hopping in the other direction. So we're starting at millimeters and we are ending up at meters, which is our base right here. All right, we're ready to hop. 1, 2, 3. All right, that means we're going to move our decimal 3 places, but this time we're going the opposite way because we're moving up the steps. So our decimal right now is imaginary behind our last 0, and we're moving it 3 times. 1, 2, 3. So this is where our new decimal goes. And I apologize, it's not sticking for me, but this is where our new decimal would go, right here. And so our new answer is 4.5 meters. There we go. And we can highlight that so you can see it here in yellow. Notice this time we moved up the stair step, which means our unit of measurement was getting larger, so our number actually got smaller. So our new number is 4.5 meters. Let's try another example. This time we're given 46 grams, and it's asking us how many milligrams that is. So we're given grams, which is a base unit, so we're going to start right here at our base. Oops, let's try that again. There we go. And we are moving to milligrams, which is down here. So we're moving down again, so we can already predict in our minds that our unit of measurement is going to get smaller, so our number will get larger. And now we're ready to bounce. We bounce 1, 2, 3. We're here. And that means we move our decimal 3 times. Right now our decimal is imaginary behind the 6. We bounce 1, 2, 3. Add our decimal right there. And fill in the zeros. We need a 0 here. We need a 0 here. And we need a 0 here. So our new answer is 4, 6, 1, 2, 3 zeros. Add your commas. We've got 46,000 milligrams, mg. And I'll go ahead and highlight our answer here so that you can see it. And I left our 4 out. Let me put that back in. There we go. There's our answer. All right, we got one more example, and so I'm going to let you try to solve this for a second on your own. So go ahead and pause the video and try to solve this on your own, and then I'll reveal the answer together so we can see if you have a good understanding. Go ahead and pause the video now. Okay, now that you've had a minute to solve, let's see what our answer should be and see if your answer matches. We are given liters, so we're starting at our base right here. We are going to milliliters, so this bottom step right here. 1, 2, 3. There we go. That means we move our decimal 3 times. Our decimal is here. We bounce 1, 2, 3. Our new decimal is now in between the 8 and the 9. And it didn't stick again for me. I apologize. Let's try it again. There we go. So our new answer is 8.9. Don't forget to label milliliters, capital L. Here's our answer. Hopefully you got the same answer on your own and you now have a pretty solid understanding of how to convert within the metric system. So thanks for watching and I'll see you next time.